And we're back again for another week of chemistry, and we would like to go live again with the second part of moles and equations. So we finished learning about how we calculate moles, the RMM, and in grams, right? But we have to take it a next step further. We have to moles and equations now, as we have to basically work out moles, molar concentration, and concentration per grams, etc., etc., and etc. So, good morning to you all again. For more of this and one-on-one sessions, you can simply join one-on-one classes and follow us at eTutorTT on Facebook and eTutorTT on Instagram as well. And you could also WhatsApp the number there at 799-5095 for further information on how to go about joining the private classes. Well, without further ado, we would like to begin our moles and equations continuation, right? So we'll just do a quick recap where it have Avogadro's constant, which is 6.02 by 10 to the 23rd particles of atoms and molecules or formula units. That's Avogadro's law. And a mole is the mass of a substance containing the same number of fundamental units as there are atoms in exactly 12 grams of carbon-12. So, what we're going to do now is to calculate the percent composition. The percentage composition is found by calculating the percentage by mass of each particular element in a compound. So, we would like to give us some moment to just look over that. Right, so we have calculated the molar mass percentage, right? So we're going to calculate the molar mass percentage for carbon dioxide, right? So to calculate the molar mass of a compound, for example, as I said, carbon dioxide, the first step we'd want to do is work out the RMM. So, calculating percentage. Right, we're calculating percentage composition. And how are we going to do that? Well, let's see. So we have carbon dioxide, right? The RMM equals, we have 12 for carbon plus oxygen is 16 by 2, which gives us a total of 16 by 2 is 32 plus 12 is 44. So the RMM is 44, right? Then what we would like to do is add the atomic, right? So we got to 44, right? That's the first step. So we're going to calculate the percentage of oxygen in carbon dioxide, right? So since we're working out the percentage of carbon dioxide in it, we have oxygen O2 equals 32% of oxygen in CO2 equals 32 divided by 44, which is the total RMM, multiplied by 100, which gives us amount at C. Let's work that out. So we end up with 72.7% oxygen in carbon dioxide. Alright, so it's pretty straightforward. You record the total RMM, you find the molar mass for whatever composition you find for, and you get the you work out percentage, right? So that's basically it. But it's not much to do with it. So we'll move along. Let's see what else we have to work out. So that's pretty straightforward. So let's see. We move on to calculating reacting masses, solutions, and concentration in grams per dm cube and moles per dm cube. Alright, so this is the heading here. Right, so that's where we're starting from. So we're working on mass per moles per dm cube. That's what we're calculating today. Alright, so we'll continue. So the equation would look something like this. Concentration equals moles, which is moles per dm cube, which, as we call formula unit, says the amount of the substance, the moles, over volume of solution in dm cube. Right? So let's go. So this general equation is rearranged for the terms as is asked in the question. So you can rearrange this equation to suit what this asks. So calculating moles. So the equation would go the amount of the substance in moles equals the concentration multiplied by volume of the solution. Another example would be, so let's work on our example here. Calculate the moles of solute dissolved in 2 dm cube of 0.1 moles per dm cube solution. Right? So we have the concentration equals 0.2 moles per dm cube, right? And we have the volume equals 2 dm cube, right? So to calculate moles now, we multiply the concentration by the volume, because you rearrange the equation, right? So we calculate the concentration by volume, and it's not 0.2, 0.1 mole. So we got moles equal 0.1 multiplied by 2, which gives us 0.2 moles. Right? Pretty simple and straightforward there. So we can move along now. Our next example, shall we? So we have, let's continue. So that's that. So let's move on. So calculating concentration now. So we have example. We have 25 cm cube of a 0.05 moles per dm cube. I'm going to just write for the equation. Right? Let's just get the equation up there. Put a little text box. So that's our question there. We have, if you have any questions, feel free to post it in the comment section. Say something there and you can ask. So we have a 25 cm cube of 0.05 moles per dm cube sodium carbonate was completely neutralized by 20 cm cube of dilute hydrochloric acid. Calculate the concentration of dilute hydrochloric acid. Now this gets a little trickier. So what we would want to do, but this is moles and equations now. So you're going to do the equation. So the first step, step 1. Just now, let's lengthen this text box out. Step 1. Calculate the amount in moles of sodium carbonate reacted by rearranging the equation for the amount of substance and divide by 1000 to convert to dm cube. So we're going to rearrange the equation. So we have molar concentration and we have volume. So we change in the cm cube to matter of fact, we do everything in one equation. So we have sodium carbonate. Let's work on that. We have Na2CO3, right? So we're going to work out how much is the volume in dm cube. So we're working it out. We have 25 cm cube, 25 multiplied by, divide by 1000, which gives us 0.025 dm cube. Right, so that's the volume there. Next thing we would want to work out is the moles. So as the equation goes, moles equals zero point 0.050 multiplied by 0.025, which gives us which gives us 0.0125 moles. Alright, so we have 0.0125 moles. Oh wait, my mistake. You have 0.00125 moles. Yeah, that sounds about right. Yeah, that's correct. So let's move along. At the first step, so we still calculated working on this. So next step, second step now. We move on to our second step. So align my text there, and we can move on to the second step now, which is second step. We calculated the amount right. Second step. Calculate the amount in moles of hydrochloric acid reacted. So now we have to put down the equation first. So we have we have Na2CO3 plus reacting with hydrochloric acid, which is HCl, to neutralization to give us NaCl plus carbon dioxide plus H2O. Now this equation needs to balance. So you'll put a 2 here and a 2 here. So now we have a balanced equation. Yeah, we have a balanced equation there. So now we have to work out the molar ratio. So we have the molar ratio being 1 to 2, right? We have a molar ratio of 1 to 2 because it's 1 sodium carbonate reacting with 2 NaCl or hydrochloric acid. So 1 to 2. Therefore, we have 0.012 moles reacting with 2 times that amount. So we have 0.00125 reacting with 0.00125 multiplied by 2, which is 0.0025. Right? So that's the molar ratio there. So you know how much of HCl reacting with, how much moles of HCl reacting with sodium carbonate. Alright, so now that we have that, we can move on to the next step. And I'd like to emphasize, for more on this, you could join our one-on-one classes online by inquiring at the WhatsApp number 799-5095. Follow us on Facebook at eTutorTT and Instagram at eTutorTT. Right, so we can continue. So after that now, we can calculate the concentration in dm³. So we're moving on to the third step now. Our third step is calculating the concentration in moles per dm³ of hydrochloric acid. Fun stuff, right? Fun stuff. So what we're going to do now, seeing that we have the moles that we worked out, and now we're going to work on concentration because we know how much the volume is we're working with. So we're working with, our first step, we'd have to convert cm³ to dm³, right? So we have 20 cm³. Let's go. We want to get 100 dm³, so we divide it by 1,000. So you have 20 divided by 1,000, which gives us 0.02 dm³, right? Now that we have the volume in dm³ and we have the moles, we can work out molar concentration. So equals, we have, now the formula goes, you're dividing the volume, the moles, by the volume. So we have 0.0, let's recap, 0.0025 divided by 0.02, and that gives us the concentration to be 0.125 mole per dm³. Right, so as you can see, that's our concentration of hydrochloric acid, and how to work out the reaction, how much reacted with how much other, with the other substance, knowing only the other substance. So again, let's recap. We'll do more examples as we move along. Let's recap from the top. So calculating reacting masses, solutions, and concentrations of solutions in grams per dm cube and moles per dm cube. So we have 25 cm cube of 0.05 moles per dm cube. Sodium carbonate was completely neutralized by 20 cm cube of dilute hydrochloric acid. Calculate the concentration in moles per dm cube of hydrochloric acid. So step 1, calculate the amount of moles of sodium carbonate reacted by rearranging the equation for the amount of substance, moles, and divide by 1000 to convert to dm cube. So we have the volume of sodium carbonate. Sorry about that. Equals 25 divided by 1000, which gives us 0.025 dm cube of sodium carbonate. Then we calculate the moles after that. So you have moles equals 0.05, which was given to us, multiplied by the dm cube, which is 0.025, which gives us 0.00125 moles. That was step 1. Step 2. Calculate the amount in moles of hydrochloric acid reacted. So we have sodium carbonate plus hydrochloric acid to give us sodium chloride plus carbon dioxide plus water. Now we balance off this equation by adding a 2 to the hydrochloric acid and a 2 to the sodium chloride, and obtaining a 1 to 2 ratio, meaning 1 mole of sodium carbonate reacted with 2 moles of hydrochloric acid. Since we know how much how much moles of sodium carbonate was used, we could use that molar ratio to deduce how much hydrochloric acid was needed to neutralize it. So we get a 1 to 2 ratio. Because it's 2 moles of hydrochloric acid to 1 mole of that, we multiplied by 2, which given us 0.0025. Then on step 3 now, which calculates the concentration in moles per dm cube of hydrochloric acid. The volume of hydrochloric acid equals, because we're working out the dm cube, because they gave us in cm cube, so we divide the 20 by 1000, which gave us 0.02 dm cube. And then for the equation part, as the equation says up here, to calculate concentration in moles per dm cube, we divide the moles of the substance divided by the volume of the substance in dm cube, which was 0.025 divided by 0.2, giving us 0.125 moles per dm cube, completing the question. If you have any questions, feel free to ask. So we'll continue. So we'll do our next equation. So we have 1 mole of calcium carbonate requires 2 moles of hydrochloric acid. So we have and I'll put the equation. So for this class, we'll just be practicing equations and how to work this thing out. Alright, so let's go. So 1 mole of calcium carbonate requires 2 moles of HCl, right? So 0.025 moles of calcium carbonate requires 0.05 moles of HCl. So calculate the volume of HCl required. Now it's an interesting one. Let's work that out. So the equation goes like this. So we have the amount of moles in the substance divided by the concentration. Right? So this is equal to, we have so we have 1 mole so you can calculate the volume for, sorry, this is a mistake here. Right. The volume of CaCO3, because that's what we know. And then we have the moles, which is 1 divided by concentration, and the concentration being 0.5. That's now wait, should be HCl. Which gives us 0.05 dm cube. What that is telling us, it takes 0.05 dm cube of hydrochloric acid to cancel out 1 mole of calcium carbonate. Pretty simple and straightforward. So let's do some other equations, shall we? Just in 1 second. Let me get some more equations. So, just a little COVID tip: stay indoors, adhere to the Ministry of Health guidelines, avoid touching the face, clean frequently touched surfaces, and most importantly, wash your hands for at least 20 seconds with soap or use hand sanitizers. Stay indoors and stay safe. We'll get through this together. Just do your part. So let me just get some more questions on moles and equations. So, we're going to calculate the number of moles of the underlying solution of the solutions given the volume. So we have let's go. Examples. Align this properly. Let's go. We're going to work out for HCl with a molar constant. We have, let's go. Let me just put this way. It should be, this is a superscript, not a subscript. Alright, so let's go. We have, first things first, to change this 25 cm cube to 25 to dm cube. So we divide that by 1000. You divide this by 1000. That gives us 0.025 dm cube. They give us a concentration, so moles equals 0.025 multiplied by 1.0, which gives us, let's work that out, which is pretty straightforward. We got 0.025 multiplied by 1, which remains the same. Moles per dm cube. Simple and to the point. Let's do our next example. Let's do a more complex question. Let's calculate the mass of material in the given volume of solution. So we're going to do it for this one. Calculating the mass of sodium chloride in this solution. So the first thing we will want to do is we'll have to calculate moles for this. So let's change this to dm cubed. So you have 50 cm cubed divided by 1000. So we got volume equals 0.05 dm cubed. We have the concentration equals 0.5 mole per dm cubed. So what we're going to do is work this out. So we're going to calculate moles, right? So mole equal volume, which is 0.05, multiplied by the concentration, which is 0.5. So 0.05 by 5. Let's put that out. So we get 0.25. 0.025 moles. That's the first step. Now we want to calculate in grams. So we need to work out the RMM for sodium chloride. So we have 23 RMM equals 23 because the RMM for sodium is 23 plus 35.5 for sodium chloride. That gives us a total of, let's see, 3 plus 5 is 8, 2 plus 3 is 5. So you have 58.5 as the RMM. So to find mass now is to find mass, it's pretty simple and straightforward as well. From last class, we just simply simply multiply the moles by the RMM, right? So mass of NaCl equals the moles by RMM. So we have 0.025 multiplied by 58.5. So that's 0.025 multiplied by 58.5, which gives us a mass of 1.4643, because we're using three significant numbers, grams. Right, so you see how everything ties in. We're able to calculate straight from dm cubed straight back to grams. So you have 1.463 grams of sodium chloride in the solution. Let's do another example. Let's do another example, shall we? Let's work it out for sodium hydroxide. So you have 20 cm cube of 0.1 mole per dm cube sodium hydroxide. First thing we want to do is calculate the volume in dm cube as usual. Which equals to 0.02 dm cube. So we have, we're going to calculate the moles. So moles equals 0.02 multiplied by 0.1, which gives us, let's work that out, 0.02 multiplied by 0.1, which equals to 0.002 moles. So the RMM equals 23 for sodium. That's not 23 plus 16 for oxygen plus 1 for hydrogen, which gives us 40. So calculating grams again. So mass of NaOH equals 40 multiplied by 0.002, which gives us a total of 0.08 grams. Yeah, that's about right. So let's do some other more complex examples. So you're going to calculate moles per dm cube. So you're going to work it out for this equation. Where my pen go now? So we have got to calculate the RMM, then work out moles first. So first things first, let's work out the RMM. we have 2 for hydrogen. So we have 1 plus 1. Let's write that properly. For hydrogen plus 32 for sulfur plus in brackets 16 by 4 which gives us 1 by 2 is 2, 2 plus 32 is 34, and then 16 by 4 is 64. So 34 plus 64 is 98. To calculate moles equals mass divided by RMM. So we have 1.962 divided by 98. So that gives us a total of 1.962 divided by 98. That gives us 0.2. 0.02 moles. The next step we want to work out is the molar concentration now. So the molar concentration, we'll arrive at that from a simple solution equation. Moles per dm cube equals the amount of moles 0.02 divided by the volume in dm cube. Now we have 250 cm cube. So we have 250 divided by 1000, 1, 2, 3, 1, 2, 3, right? So that gives us 0.25 dm cube. So put a 0.25 over here, and we work that out. Which gives us a concentration of 0.08 mole per dm cube. See? Simple. Let's do a next example. Let's do an actual question, a next question now. Let's do a question. Yeah, question will be cool. And this will be a question to end off the class. So once you complete this question, we'll call it a class. Alright, so this is the question. We have 25 cm cube of a solution of 0.2 moles per dm cube, sodium hydroxide reacts with 30 cm cube of a solution of nitric acid. What is the concentration of the acid in moles per dm cube? Now, the first thing we want to do is write out a little equation. So let's go. So we have KOH plus HNO3 to give us another acid and a base reaction. So we get salt. So we'll get KNO3 plus H2O. The equation has already been balanced, so you don't have to worry about that. It's a 1-to-1 ratio. So first things first, we want to do is work out how much moles in the potassium hydroxide. We're going to have our equation. So you have to change that to dm cube. So you have divide this by 1,000. So to work out moles equals 0.025 multiplied by 0.2, which gives us 0.005 moles. So you have reacting with 0.005 moles. So we know the moles of the acid now. So we're going to say, and we have how much cm cube, to divide this by 1,000. So sorry about that. Right, moles the dm cube equals 0.005 because is moles divided by volume, and the volume is 0.03, which gives us, let's work that out, one point, sorry, 0.167 moles per dm cube. That takes care of this question. So you have 0.167 moles per dm cube of nitric acid reacting with, no, you have the concentration of the acid is 0.167 moles per dm cube. Right, so that gives us the answer, how to calculate the concentration given a situation. So that would be it for today on calculating moles and solutions. Just remember, you could subscribe to our YouTube page for more. You could follow us on Facebook at etutortt and Instagram at etutortt. And you could contact 799-5095 on WhatsApp to inquire about joining one-on-one classes. Right, so that will be all for today. Just remember, as a safety tip, stay inside, keep that social distancing of 6 feet apart, and wash those hands for at least 20 seconds with soap or use hand sanitizer, and avoid touching the face. That will be all for this week. We'll be back next week at the same time, 11 a.m. for more chemistry classes. So take care, have a great week.